This is part 2 of the lecture for section 2.1. In part 1, we covered vocabulary, function notation, etc. And in part 2, now we're going to talk about graphs of functions. So the first example is just creating a graph using a table. Later in this chapter, we will learn more efficient ways of graphing things, but for now it's just going over just the basic process of finding ordered pairs and plotting them. So this first problem asks us to graph two functions that are related to each other on the same coordinate plane and then describe the relationship that we notice. So our first function is f of x equals x squared, and our second one that we're going to graph is g of x equals x squared minus 3. All right, so over here is the table for the first function. So we have a column that represents our input or our domain, x, and then the other column is going to represent our y values, or f of x, which is found by using our definition, x squared. So I'm going to choose just a subset of the real numbers, -2, -1, 0, 1, and 2 as my input values, and plug those into my function to find my y coordinates. So if x is -2, if I square -2, I get 4. If x is -1, -1 squared would be 1. If x is 0, 0 squared is 0. X equals 1 means 1 squared is 1, and x equals 2 means 2 squared is 4. So I have 5 ordered pairs that I can plot. So the ordered pair -2, 4 on my graph, -2, 4 would be up here. -1, 1, so -1, 1 is right here. 0, 0 is the origin. 1, 1, over 1 to the right, up 1, right here. And then 2, 4 would be over 2 and up 4, which is up here. So that first set of ordered pairs shows this U-shaped graph right here for f of x. Okay. Our next function we're asked to graph on the same coordinate plane is g of x equals x squared minus 3. So again, we set up the same way, choosing these values for x, or they might give you values that they're asking you to use for x. If not, you just choose your own set of x values. And then g of x equals, this time, x squared minus 3. So for -2 as the x value, -2 squared minus 3, 4 minus 3 would be 1. If -1 is our x value, -1 squared is 1, subtract 3, -2. 0 squared minus 3 is -3. 1 squared, again, 1 minus 3, -2. And 2 squared minus 3, 4 minus 3 is 1. So plotting these ordered pairs, -2, 1. So -2, 1 is right here. The next one is -1, -2. So -1, -2 is down here. 0, -3. So when x is 0, we're here. Y is -3, down on the y-axis. 1, -2, so over 1, down 2, right here. And 2, 1, over 2, up 1 is up here. So these points, again, line up in the same shape right here, this U-shaped graph. Notice that they're similar in shape because their basic form is the same, but they're slightly different because obviously they're not exactly the same equation, right? One thing we would notice here is that the graph of g of x is the same as the graph of f of x, but it got shifted down 3 spots. And we'll look more at those types of relationships later on in section 2.5. But for here, it's just plotting points and then looking at their relationship on a graph. All right, next we'd like to be able to use a graph to determine whether or not we have a function. And to do that, we use what we call the vertical line test. You may have seen this before if you've learned about functions in a previous course. The vertical line test says if a vertical line can be drawn that touches the graph more than once, then the relation is not a function. Because if that happens, if you can draw a vertical line, that means you're choosing one value of x, and if it touches the graph more than once, that means that value of x corresponds to more than one value of y, which violates the definition. So just a couple quick examples of using the vertical line test. So let's look at this graph first. So here we just have a slanted line graph. No matter where I draw a vertical line, I'm only going to touch that line one time. So that would be yes, this is a function. However, on the second example, this time we have this sideways U. Here, I could draw a vertical line that would touch that in more than one place. So that would make this not a function. So in this case, we were shown that x value looks like -3, right? Corresponds to a y value down here at -2, but that same x value also corresponds to a y value up here at +2. So that makes this not a function. All right, and then our last thing that we need to be able to do with functions is use a graph to find function values and to answer other questions about our function. So this example, this graph is provided, it was given to us, and then the questions they're wanting us to use it to answer are these. Find f of -4, find f of -2, find f of 3, and for what value of x is f of x -1. So this time we don't have an equation to plug numbers into, so we have to understand what to look for on the graph. So for part A, f of -4, remember this number here represents the x value, and I'm looking for what the y value is. The function value represents y. So this is asking if x is -4, what is y? So over on my graph, I find the x value -4, which is back here. And then I go find my graph. My graph is up here. And that y value that corresponds to is 2. So f of -4 equals 2. Part B, f of -2. So this time I find the x value -2, which would be here. Y value up here on my graph is about right there, and that corresponds to the y value of 1. So f of -2 would equal 1. And then part C, f of 3. So this time I'm going to go over here to x equals 3, and then go find my graph, which would be down here, and that is on this path of this y value right here at -2. So f of -3 equals the y value -2. For part D, it's backwards. It's saying for what value of x is f of x, meaning y, equal to -1. So this time you're looking for the y value of -1, and they're asking you to find the x. So on my y-axis, I go down here to -1, and then I go over to find my graph, which is over here, and then I'm reading off what x is, which would be x equals +1. Okay. All right, and then our last one is kind of tying a lot of things together. They're asking us to use a graph to find domain, range, X-intercepts, Y-intercepts. Those are the places where it crosses the x-axis and the y-axis. And then missing function values indicated by question marks below the graph. So they've got some function values to identify down here. All right, so this was our given graph. Part A says find domain. Now before, when we found domain, we had to list individual values of x because we were given a finite set of points. This time we are given a graph, so we have to, remember, represent the domain by indicating all values that x could be. All right, so here we've got arrows on the ends of our graph, so that means that as I were to move off of my grid, this would continue to move down and left. And over here I would continue to move down and to the right. In other words, the pattern would continue. Right, and then otherwise all values of x are used somewhere. This is going to continue to move to the right and never stop. This end's going to continue to move left and never stop. So every real number on the x-axis could be part of my graph if I had enough space. So this time I have to use what we call interval notation. Okay, so if it expands as far left as you can go and as far right as you can go, if you were to extend the pattern, your domain would simply be -infinity, +infinity, meaning all real numbers on the number line. Parentheses on the ends because infinity is not a stopping point. We only put a bracket on the end if we're stopping at a given value. Okay, range we treat the same way, looking for a set of real numbers that we'll have to state using interval notation. Remember, range are y values. So since this extends downward forever, we start with, in our interval notation, you must list the smallest value of your interval first. So you're looking from left to right for domain, bottom to top for range. So if the bottom is continuing down forever, we'd start down at negative infinity, comma, and then this one will never go higher than this spot right here, right? This is the highest y value that this graph will ever touch, and that is a y value at 4. So the lowest negative infinity, comma, up to the highest value of 4, and we put a bracket on the 4 because it reaches the value of 4, so that 4 is included, but it never goes higher. So in other words, 4 is a stopping point. So this means all y values in between those endpoints. Part C says X-intercepts. This is the places where the graph touches or crosses the x-axis. So here's my x-axis, so it's touching here at negative, or crossing at negative 3, and then again over here at 1. So x equals negative 3 and 1. Part D, Y-intercepts, means look on the y-axis and you're listing where the graph touches or crosses. So right here at 3, so y equals 3 is the y-intercept. And then our missing function values indicated by question marks are down below, f of negative 2 and f of positive 2. So just like we did on the last example, f of negative 2 means find x equals negative 2. Then go up here, find wherever my graph is there, which is at this spot, and the y value right there is at 3. And then for f of positive 2, we go over here to positive 2. And then I'll find my function, which is down here, and it looks like it's going to cross right when it gets to this corner, which would be at y value negative 5. All right, we're going to try one more with the same directions. So this time we're looking at this graph and answering the same questions. Domain. Notice these endpoints do not have arrows, they have open or closed circles. So this domain and range have a beginning and an ending, but a parenthesis versus a bracket based on whether it's included or not. So the start of this graph is an x value negative 6, but that number is not included because of the open circle. So we start our domain with a parenthesis and then the negative 6 as the beginning x. And then it extends all the way to here, and remember the x value right here is 0, and it's included, right, with the closed circle, so it stops at 0 and we put a bracket. Range, y values from bottom to top. So the bottom of the graph is here, the y value right here is negative 3 and it's included, so we start with a bracket, negative 3, comma, and then all the y values up until here. This y value is 4, but the open circle means we're not including it. So it stops at y value 4, but the parenthesis indicating to not include it. Part C was x-intercept, so it crosses my x-axis at negative 4. So x equals negative 4 is the only x-intercept. Y-intercept is down here at negative 3, where it hits the y-axis. And then my missing function value, f of negative 4, means if x were negative 4, right here, what is the value of y? Well, if it's on the x-axis, the value of y is 0. So f of negative 4 equals 0. Okay, that is the end of section 2.1.